All right. Um, Analyzing the graph of a quadratic equation. This is a two example scenario because we will do one when the graph is in standard form. And we will do one when the graph is in general form. So I will do this by example. So when you have your function right here, so we're going to use this same equation throughout. We're going to analyze it, figure out what are the important parts of the graph. My equation is x squared minus 6x plus 8. Before we start our analytics, first thing we're going to do is we're going to identify the parameters. Now, as the numbers change, we know we're going to get a quadratic, but it'll be look differently. So we got to figure out how do these numbers a, b, -6, and c8 affect the graph. Your a, b, and c are key to the graph, and so it's the first things we want to identify. Now that we have identified a, b, and c, we have a multi-step process to break down the graph right here and use that process to take us to a better understanding of the graph. First step is you want to determine the shape of the graph. So you want to determine now the rule is simple. If a is greater than 0, the graph will open up. And so the parabola will look like this. If a is less than 0, then the graph opens down. And the graph will look like this. In our example, a is equals to 1. So for our example, our parabola is going to open up. One step down, 55 million to go. Woo-hoo. That's the first step right here. The second step is to find the y-intercept. Find the y-intercept. Remember that if you're looking for the y-intercept, you set the other letter equal to 0. So if I'm looking for the y-intercept, then I set x equals 0. And so that is f of 0, plugging 0 for x. 0 squared minus 6 times 0 plus 8, which is equals to 8. And so my y-intercept is going to be 0, 8. So I know my graph opens up and it goes through a y-intercept of 0, 8. By the way, there is a simple shortcut. The y-intercept will always be 0, c. Because the other two terms, the a and b, get zeroed out. So your y-intercept is always 0, c. So you can technically shorten this step by just a little. So my graph opens up. It has a y-intercept of 0, 8. Step number 3 is find the x-intercepts. So 1, 2, 3, find the x-intercepts. And again, if I'm finding the x-intercepts, then I am making y equals 0, or I am setting the entire equation equal to 0. Now you can solve this equation in one of several ways. You can complete the square, you can use a quadratic formula, you can factor. And so the rule is you always take the one that is fastest to get you to your answer. And in this case right here, the fastest way will be to factor this equation. So after some trial and error, I got x minus 4 and x minus 2 equals 0. And so therefore, you will get that x is equals to 4 and x is equals to 2 after you've worked it out. And so my x-intercepts are 4, 0 and 2, 0. As you can see, we were getting information about our parabola. It opens upwards. Y-intercept 0, 8. X-intercept 4, 0 and 2, 0. The next step is to find the axis of symmetry, IV. Find axis of symmetry. Now, there are several ways of finding the axis of symmetry. The simplest way is to use the knowledge we have already. So if I go this way, and I go this way right here, I know my parabola opens upwards, and it has an x-intercept. So 1, 2, 3, 4. It has an x-intercept at 2, and an x-intercept at 4. And it goes like this. A parabola. It's a bell-shaped curve. It's opening upwards. I know all of this right here. The axis of symmetry must be the mirror line, and so it must cut the graph exactly in half. Obviously, my graph is not drawn to scale. So what's halfway between 4 and 2? Clearly, the answer is 3. And so my axis of symmetry, it is a vertical line, and vertical lines have the equation x equals. It will be x equals 3. Now that's the fastest way to find axis of symmetry. It is halfway between the x-intercepts. Now, sometimes a graph doesn't have x-intercepts. It's possible. So is there a different way of finding the axis of symmetry? And the answer is yes, there is. The axis of symmetry also has a formula associated with it. The axis of symmetry is a vertical line, so it's always x equals. And you use two parameters, negative b divided by 2 times a. Those two parameters right here, divided in that form right here, gives you the axis of symmetry. So again, in this example, so x will be equals to minus b. B was negative 6. And so that's minus negative 6 divided by 2 times 1. And that gives us 6 over 2, which gives us the answer we expected. X equals 3. Well, you might be thinking, well, where did they get this minus b over 2a? It kind of looks like the b over 2 squared, but it's not the same thing. Where did they get it from? Well, the quadratic formula is x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. These two right here represent the two x-intercepts. If I go halfway between the two x-intercepts, this part of the equation will drop off and leave me with simply minus b over 2a. And that's where the formula comes from. So that's how you find your axis of symmetry. Axis of symmetry right here, minus b divided by 2a. Step number 5. So again, as you see right here, we're getting more detail and more information about my quadratic function. Again here, the next step is to find the vertex. The vertex is this point right here at the zenith of the graph. It is the lowest or the highest point. The vertex always aligns with the axis of symmetry. And that is an important point on the graph. So step number 5, find the vertex. The vertex V is always x equaling the axis of symmetry, and the y value you have to calculate. So for my vertex for this graph, I have already found the axis of symmetry, so my vertex will be at 3, and to fill in the missing point right here, I just use the equation of the graph. And so I will find f of 3, plug the x value into the equation, and that's going to be 3 squared minus 6 times 3 plus 8. That is 9 minus 18 plus 8, and that is equals to negative 1. And so my vertex will have coordinates 3, negative 1. And so my vertex is going to be 3, negative 1. I know the vertex. I know the axis of symmetry. I know my x-intercepts, I know my y-intercepts, I know the graph opens upwards. And so with all of that right there, that takes me to step number 6, which is the easiest step of them all, and that is I have to graph the function. Graphing the function is not that hard. I know I need an 8 over here. 1, 2, 3, 4, 5, 6, 7, 8, because that's the y-intercept. I know I need 1, 2, 3, 4. 2, 3, and 4. And I know I need a -1. First things first, the graph opens upwards. But that's a natural artifact of the graph. The y-intercept is at 8, 0. The x-intercepts are at 2, 0. Y-intercept is 0, 8. And the x-intercept is at 4, 0. The axis of symmetry splits the graph in half. Always write the axis of symmetry as its full equation, x equals 3. The vertex of the graph is at -1, 3, so the vertex graph is right here. And I know the graph opens upwards. So carefully now, there we go. I have my graph of my problem. Give it a name, they like to be named. X squared minus 6x plus 8. The remaining step asks us to simply analyze the graph that we have in more detail. Step number 7 is to find the domain. The nice thing for the domain for all quadratic equations is that they're all polynomials, and so their domains always are real numbers. The range is a little bit more tricky. The range is the lowest y value, which occurs right here at the vertex, to the highest y value. The graph goes up forever. And so my range will be a low of -1 and a high of infinity. A low of -1 and a high of infinity. And that's going to be my range right there for my graph. Number 9, the maximum value. This graph right here opens upwards, and so therefore it will have a minimum value. It has no max because it's going up forever. So it has a minimum value. And that minimum value is the y-coordinate of the vertex. That minimum value is the y-coordinate of the vertex. And so it has a min of -1, min value of -1. The last step is to show where the graph is increasing and decreasing. To do that, we have to inspect the graph carefully. The graph has two sides to it, a side over here and a side over here. If I trace the graph with a pencil, I will go down, followed by going up. And so we see that the vertex, the axis of symmetry, splits the graph into two sides, a decreasing side and an increasing side. And so the graph is decreasing from, watch carefully, we cover the x-axis. See where I have shaded right here on the x-axis? That's where the graph is decreasing. So the graph is decreasing from -infinity to 3, and then the graph is increasing from 3 to infinity. Right here. And that's the graph of the function. That's us analyzing the graph of that function right here. Okay. We will do this again, but this time with a graph in general form. It will actually be the same 10 steps, the difference being that the the equation is different. Other than that, the intercepts are the same.